Welcome to Blurry Cam Theaters presents a Moles review. All right, let's do this thing. Hopefully this camera setup will work really good, and I won't have to be messing with it anymore. Okay. All right, moles unit review. What is a mole? A mole is just a number. It's just a number, and in this case, it's Avogadro's number. And it's 6.02 times 10 to the 23rd. That's all a mole means. When it says how many marshmallows would be in a mole of marshmallows, well, a mole's a number. It's just like saying how many marshmallows are in a dozen marshmallows. Well, you know a dozen is just a word that means a number, 12. A mole is just a word that means a number, 6.02 times 10 to the 23rd. Now, when we talk about mass in terms of mole, this many atoms of something weighs what's called a molar mass, or gram formula. Now I'm breaking my own pencil. Gram formula mass, molar mass, or gram formula mass. You can call it whatever. I always call it molar mass. I know other teachers call it gram formula mass, so let's get along with everybody. All right. So a molar mass is pretty easy. In 1 mole, all I have to do is grab the periodic table. Anytime I see grams or molar mass or mass that I know indicates grams, that means grab your periodic table. When they ask me what the molar mass of lead is, I know that all I have to do is look at the periodic table. Let's see if I can get that glare out of there. And that lead's mass per mole is 207.2 grams. So this is 207.2, and the units are grams per mole. Okay? That's all you're doing. Molar mass is the easiest thing. That's why they put it on here first. It's just adding stuff up. I've got 2 chlorines at 35.5 apiece, so that's 71. 71 for those. And I have a calcium at 40.1, so 40.1 plus 70.1 is 111.1. Is that right? See, without adding things up in a calculator, I'm going to get as bad as y'all. 70 plus 40.1. 110.1. 110.1. Oh, Erwin, your math skills. Your math skills are in decline, sir. Okay. 110.1 grams per mole. CuSO4. I got 1 copper. It weighs 63.5. Let's see if I can get it out of the glare there. 63.5. So 63.5. I have 1 sulfur. It weighs 32.1. 32.1, and I have 4 oxygens, and they weigh 16 apiece. 16 times 4 plus 32.1 plus 63.5, 159.6 grams per mole. And then Ca3PO42. And remember what that 2 means is that I have 2 whole PO4 groups. So I have to multiply that times the subscripts. So I have calcium 3 times, on the periodic table, 40.1. I have phosphorus, which is 2 times 1, which is 2 times 31. 62. Oop, you can't even see my work here. 3 calciums times 40.1. Let's just go ahead and do it. 40.1 times 3 calciums is 120.3. And then I have 8 oxygens times 16 is 128. And that is 8 oxygens times 16 equals 128. Plus 62 plus 120.3, 310.3 grams per mole. Okay. these I'm pretty confident you can do on your own. This is the new style video we're going to do where I do examples and then you just follow along and do what you do on there here. So I can only work the ones that aren't in the box if you're wondering. Okay. All right, molar conversions. You know conversions. The way I teach it in my class is you have this, a dimensional analysis box. And what goes here is what's given, 2.7 moles of calcium chloride, CaCl2. Okay, so everything in my class is by rules, and the rules only apply to units. So do not try and stick numbers in here until I stick units in here. So I know by the diagonal rule that these units go down here so that I can cancel them. So I have moles of CaCl2. And up here, I know that I'm going to molecules. So I know that I'm going to end with molecules of CaCl2. What the heck? I may have to go find some gas here, maybe. I don't know. Molecule CaCl2, and that the units of my answer back into this top right box. Molecules CaCl2. Now it's just a matter of what conversion goes in here. Well, I only know two conversions. I know that 1 mole equals 6.02 times 10 to the 23rd atoms, molecules, particles, formula units, anything you want to call it. And I also know that 1 mole of atoms, that many atoms, weighs the molecular mass of that element in grams, or elements, that whole compound, in grams. So what am I going to use here? I have molecules and moles. Well, I can't use 1 mole equals grams of molar mass, so I must use 1 mole equals 6.02 times 10 to the 23rd atoms. Hey, here's a good hint. Whenever you write mole in this conversion part, it's always 1. Always. Always 1 until next unit, and then we'll do a different conversion. But we'll burn that bridge when we get to it. So 1 mole equals this many molecules, 6.02 times 10 to the 23rd molecules. So now it's a math problem. Now it's just entering it into a calculator. And you're multiplying by everything on top and dividing by everything on bottom. Now, if I divide by 1, it's just the same answer. So you know that the multiplication part, 2.7 times 6.02 times 10 to the 23rd, equals 1.625 times 10 to the 24th. So there's my answer, right? Now, I want y'all to look at your answer and see if it makes sense. Because sometimes you're not. You'll get these outlandish numbers, or you'll put numbers in the wrong place, like 6.02 times 10 to the 23rd moles. That would be all the atoms in the universe. So molecules. Molecules are very small, so it should be a big number. 24 zeros out past this, or 21 zeros out past this. That makes sense because molecules are small. Make sure your answer makes sense. Here I'm converting to moles, so it shouldn't be a 10 to the 24th number. Moles should be smaller than that. A mole is this many molecules, so it should be smaller, right? All right, but it's the same setup every time. It's a dimensional analysis. And give yourself plenty of room. I don't know how many times I see people trying to cram a dimensional analysis into one corner. Give yourself room, people. The answer doesn't take up that much room. We're not trying to save that side of the paper. Okay, so what am I given? I'm given goes here, 2.59 times 10 to the 24th molecules of CO2. So whatever units up here must be units down here. Molecules CO2. And then what is my answer going to be in? We're in moles CO2. moles CO2. Okay, again, I only have one conversion that works for this with moles and molecules, and that is 1 mole is 6.02 times 10 to the 23rd. And now you see why memorizing where numbers go is pointless. Up here it was on top, down here is on bottom. So, now here's the critical thing. When entering this into the calculator, can I get the glare off? There we go. We're going to do open parentheses 2.59 times 10 to the 24th. Oops. Over close parentheses divided by open parentheses 6.02 times 10 to the 23rd. Close parentheses, enter. 4.302. I love that answer. 4.302 moles of CO2. And that seems logical. There's no times 10 to the 23rd because it's moles. If it was molecules or atoms or particles or any of that, then yeah, you'd absolutely have that answer. But not here. Not necessary. Okay, let's do the next one. We're just going to crank through these next two because it's just conversions. My given goes here, 3.8 moles of sodium. 3.8 moles Na. Same units down here, has to be. No ifs, ands, or buts. It must be the same units. Moles Na. And what am I converting to? A mass in grams. Grams of Na. Grams of Na. Okay, now I have a decision to make. Is it 1 mole equals 6.02 times 10 to the 23rd grams? No. Grams are much bigger than atoms, particles, or molecules. Grams are this. This many atoms weighs this in grams. So 1 mole of sodium, and I always say to my students, G stands for grab your periodic table and start adding. If you're not grabbing your periodic table, then you have no idea about how many grams. So 1 mole of sodium. Let's find sodium right here. 23 grams in 1 mole. 23 grams and, oh, sorry. God, look at me putting it in the wrong place like an idiot. I was looking at the screen. I'm sorry. Okay, 1 mole is 23 grams of sodium. Now it's a math problem. 3.8 times 23. 3.8 times 23. 87.4. 87.4 grams of Na. And that's a good answer. All right, let's do this last one. We're going grams to moles. I can do that in one step. It's no problem. We're going to go from 415 grams of potassium sulfate, K2SO4. Sorry about the noise. The room screams when everything's shutting down. If I have grams of K2SO4 here, I have grams of K2SO4 here. There's no question. That's just how it has to be. And I'm converting to moles, so the units of my answer are moles K2SO4. Moles K2SO4. And now, again, I have to make a decision. 1 mole, I know it's always 1 mole. I only ever use 1 mole. Do I put grams down here? What do I put for grams? 6.02 or a molar mass? Well, it's a molar mass. It's always a molar mass. So G stands for grab your periodic table. I have 2 potassiums at 39.1 grams apiece. 39.1 times 2, enter. And I have K2SO. I have an S, a sulfur at 32.1. Enter. And what else do I have? I have 4 oxygens plus 4 times 16 in parentheses. See how I'm doing that? And that's 174.3. 174.3 grams per 1 mole. So then I just have a math problem, 415. And I can do 415 times 1 if you want to multiply everything on the top. But if I enter, it's still 415 divided by 174.3. Enter, 2.3809. 2.3809 moles of K2SO4. All right, I'm going to stop this video here, and I'm going to continue page 2 on the next video because this one's getting a little long. I'll see you guys in a second.